Hello everyone, welcome back. In today's video, we are going to learn about concurrent processes and the principle behind, and also a classic example, producer consumer problem. So, in today's video, we will understand what processes are and how they work, the principle of concurrency in operating system, and the famous producer consumer problem. So, let us get started. Firstly, what is a process? So, a process is like a program in a execution. Example, think of a music player app. When you open the app, a process is created. When you press play, the process starts executing. If you pause the song, the process is waiting for input. Each process goes through different states. What are those states? We have already learned about them. And the new, ready, running, waiting, and terminate state. In the new state, the process is being created. In the ready state, the process is waiting for the CPU time. In running, the CPU is executing the process, and waiting, the process is waiting for some event or any resource required for the execution. Then termination. The process has finished execution and is stopped. So multiple processes can run at the same time, which brings us to concurrency. If multiple processes are running at the same time, we will be learning about a concept called concurrency. So concurrency is when multiple processes run simultaneously in a system. When a number of processes are running at the same time in the system, that is concurrency. But wait, can a CPU really execute multiple processes at the same time? Let us think about that. If a system has one CPU, it switches between processes very quickly using context switching, creating an illusion of parallel execution. What? If a system has one CPU, it switches between processes very quickly using context switching, creating an illusion, not a real but illusion of parallel execution. And then, if a system has multiple CPUs, it can truly execute multiple processes at the same time. So, the answer to our question is yes, a CPU can execute multiple processes at the same time or simultaneously. For an example, think of a restaurant kitchen. A chef can only prepare one dish at a same time because it is a single core CPU. But with multiple chefs, if the restaurant is bigger, they are like the multi-core CPU. Multiple dishes can be cooked at the same time and can be served to the user. But it's not easy in concurrency. There are some major issues in concurrency. Firstly, concurrency is very powerful, but it also has its own challenges. When multiple processes share resources, problems will definitely arise. Some of the problems are like race condition. So, when two processes try to modify a shared resource at the same time, it can lead to incorrect result. What? There are two processes. They are trying to modify a shared resource. For example, there are processes A and B, and they both are trying to modify a shared resource C at the same time, then it will definitely lead to incorrect result. An example, two bank transactions withdrawing money at the same time from the same account. Okay, then we have deadlock. We have studied about deadlock in the previous lecture in detail. You can go and watch that topic if you want to know about deadlock in detail. It means that what is deadlock? When two or more processes wait on each other indefinitely, they are stuck forever. For example, there are two drivers facing each other on a one lane road, both refusing to back up. There is a one lane road. There are two drivers from here and from there. They are both at the same time, and none of it is ready to back. So they will be on deadlock for forever. Yeah, that is deadlock. Then we have starvation. It means that CPU will never gets a processor will never gets the CPU time because other high priority processes always run first. Let me give you an example like there is a new employee, but he is never getting a chance to speak in meetings. Why? Because senior always dominate the discussion. The senior will always try to manhandle the employee. So that is starvation. But to handle these problems, as always, if there are problems, there will be solutions. We have synchronization mechanism like semaphore and mutex. We use those, but we will explore those in another video. Without let's move further. Let us look at the producer consumer problem. It is a very famous problem from some time. In the producing consumer problem, what happens is that it shows concurrency, that shows how processes share resource safely. Let us imagine the scenario. There is a producer which creates items and adds them to a buffer for later use. There is a consumer, it takes items from the buffer and uses them. The buffer has a limited size, so the producer must wait if it's full and the consumer must wait if it's empty. Uh, Let us take a real world example. In a bakery. In a bakery, the baker, who is the producer, it makes bread and places it on a shelf. There are three things: the baker, the shelf, and the customer. Okay, so the baker produces the bread and places on a shelf. The customer takes the bread from the shelf. If the shelf is full, the baker cannot place any more bread on the shelf, so he will wait for it to be empty. But if the shelf is empty, the customer must also wait for the fresh bread to arrive. The problem, without synchronization, the producer and consumer problems might access the buffer at the same time, causing data corruption. But to solve this, we use synchronization. To prevent issues like this, we use two synchronization technique. The first one is semaphore. It will signal. Semaphore will signal when the buffer is full or empty. It will tell the baker and the customer if there is bread or not. Then we have mutual exclusion. Ensures that only one process can access the buffer at a same time. It means that either the baker or the customer can access the shelf at one time. That is mutex or mutual exclusion. So today we have learned about Today we have learned about processes, which are programs in execution, moving through different states, then concurrency, which allows multiple processes to run together, but introduces issues like race conditions, deadlock, and starvation. The producer consumer problems demonstrates the need for synchronization to manage shared resources. So, understanding concurrency will help us how we can operate systems on the operating system efficiently with handling multiple tasks. If you found this video helpful, hit like, subscribe, and comment below if you have any questions. See you in the next video. Thank you.